So today I will be discussing about the potentiometer. So we have two applications. One is the comparing the EMF and one is the determining the internal resistance. So today I will be doing the determining the internal resistance of the cell. Now let us see how to do the connection of the internal resistance of the cell. Theory we have already done. Let us see the connection now. Okay, let us see the connections now. So this is a potentiometer bridge. Okay, so this potentiometer bridge, you can see there are total 10 wires. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are total 10 wires. And you can see one scale above it. Okay, so this scale is from 0 to 100 centimeter. And one more scale below is also there. Okay, so why this scale is used, I will be showing it. Firstly, let us see the connection now. You see, there are 2 points. This is one point A and this is supposed if I consider as point B. Okay, so I'll be starting from the point A. See this, from starting from the point A, this point is connected to your rheostat, as you can see. This is connected to the rheostat. Then from the rheostat, this wire, as you can see, okay, this wire is connected to this ammeter. Okay, to the negative terminal of the ammeter. Then from the positive terminal, this is connected to the battery eliminator. Okay, so as you can see, this is connected to the battery eliminator. And from the battery eliminator positive terminal, this is connected to the point A, or you can consider as a point B. Okay, this is one connection, one part of the circuit. Okay, this is a primary circuit. Then in the secondary circuit, this is connected to the positive terminal, that is to the cathode. Okay, so this is a cathode. So it is connected here. Then this cathode is connected to the resistance box. Okay, as you can see, this is the resistance box. And from the resistance box, it is connected to the one-way key. And this is connected to this resistance box. One more resistance box. Okay. This resistance box that you have connected, this is nothing but your shunt. This is a shunt resistance. Okay. And this resistance box is connected, then which is connected to the galvanometer. And from the galvanometer, this is connected to your jockey, which we have to tap it over the wire. Okay, then after that, what we have to do, so when you switch it on, you can see the battery voltage is given here 02468, you make it to 2 volt. Okay, then switch it on. After switching it on, we have to see the circuit whether it is correct or not. Like suppose if I use this jockey, if I put it here, okay, like suppose if I switch it on. Okay, now you can see this, when I put on the first wire, you can see the galvanometer is getting deflected on the left hand side. When I put on the last wire, this should be deflecting on the right hand side. If it is deflecting on the right hand side, that means your connection is correct. Okay, now, how to do the calculation now you see. What I have done, in the resistance box, I have disconnected 100, so 1500, 1700, 1900, 2000, 2050, 70, 2090, then it is 2100 and 2105. So I have disconnected. This is the resistance in the circuit. Okay, 2105. Then what we have to do, this is your Laclangi cell. Okay, this Laclangi cell, it consists of a cathode and it consists of an anode. And the solution, that is the electrolyte that we are using here, this is nothing but your ammonium chloride. Okay, this provides the battery voltage around 1.5 volt, nearby 1.5 volt, not exactly. Okay, then you just tap over the wire. Like suppose when I tap over the wire, okay, this should be first condition. This should be switch off condition. Okay, I have plug off one key from here. Okay, so when you tap on this wire, suppose your galvanometer is getting deflected zero here. Okay, like suppose this is a zero deflection, as you can see here. Now you compare this with the point. One we are getting 19 and one we are getting 18. Now you see, which wire you will be using here? Since you are using the upper point as A point, so this will be, for this wire you have to use the upper scale. And for the second wire you have to use a lower scale. Okay, then for the third wire again you have to use the upper scale. That means in the alternate way, you have to use the upper scale and the lower scale. Clear? Suppose when I am getting the reading in the fourth wire, here I am getting as here. Okay, the fourth wire. Second and the fourth wire you have to use a lower scale. That means you have to use the lowest point, that is the 19 centimeter. Okay, that means here your reading will be from that side 0 to here it is 99, then 101, 102, 103, it will be going on that way. Then again it will be 199, then again this will be 201, 203, it will be 299 here. 301, 302, that means here the reading that will be getting here 318 centimeter. This is the first reading. This is the first balancing length. Second balancing length, what we have to do, this key you have to connect it. Now your the resistance box is connected now. This is your shunt resistance. Again, you gently tap off the wire, see the galvanometer reading where you are getting. Okay. Then after that, what we have to do, you have to use a table, you see. So this is a table. Ammeter reading without shunt resistance, that means when you switch off the resistance box, that is a shunt resistance, we have to see the balancing length. Then with the shunt resistance, you have to see the balancing length. Then the shunt resistance what we have used. Then the internal resistance formula is R is equals to L1 minus of L2 by L2. You have to put the formulas values here. Okay, so this is how we have to do the calculation of internal resistance. Okay, so this much for today. Thank you.